and welcome to this vSuite version 0.4 video tutorial. And in this video tutorial, I'm going to cover some of the ways that you can set up a parametric EnergyPlus simulation with the EnVi component of the vSuite. Like the parametric Radiance analysis done with the LiVi component, which uses the Blender animation system to set up the parametric simulation scenario, it's exactly the same process here. We use Blender animations at the object level, mesh level, or parameter level to then set up and automatically run a sequence of simulations based on these variations. And I'm going to run through these three main ways of setting up this parametric simulation in this video. So I'm just going to start with a super simple scene. Just a single room, just walls, floor, roof, and one window. And that window currently points south. Now, I've got down here a sort of bog standard EnVi node setup. I've turned on temperature, heat in watts, and solar gain as the results outputs. And I've set up an HVAC node to provide heating to this zone to a minimum of 20 degrees Celsius. So we can also see here that we've got a VI chart node, and that's currently showing some of the results from this single simulation. And you'll notice we've got this option up here. We've got this option up here. And this only has static in it right now, but this option will become important later when we do a parametric analysis. And we've also got a CSV export node, and that just has the export CSV file button in it. But again, that will change when we do a parametric analysis. The main controller for an EnVi parametric analysis is this animation option here. And this will ask us then for the start and end frame of the Blender animation, which is going to be the setup for the parametric simulation. For the moment, I'm going to turn that off because first we need a Blender animation that we can use as the basis of the parametric scenario. So I'm going to come into my 3D view, and what I'm going to do is I'm going to set up an animation of this object or EnVi zone at the sort of object level. So a change that encompasses or applies to the entire object. And there are various different parameters you can animate, but I'm going to animate the rotation of this object. So I'm going to animate it through 360 degrees. So the window will paint south. The window will point south. It will point north, and then it will come back and point south again. Now, in the sidebar of the 3D view, we have some transform options for the object, and it's the rotation of the object that I'm going to change. So what I need to do is I've opened up a little animation timeline window in between my 3D view and my node editors. And this animation timeline tells you what the maximum minimum nominal frame range is for this current Blender project. And it tells me what my current frame is. And my current frame is 0 of a range of 0 to 10. So with 0 here, I can now come to my rotation panel and I can press I for insert keyframe. And that means that the values here in this rotation panel have been registered to this frame 0. I can now go to frame 10, the end of my frame range, and I can change the Z rotation to 360, and I can press I again. Now you might have noticed that before I pressed I, these values were green, or after I pressed I first time, they went green. If these values are yellow or yellowish, it means that this value has been registered to the current frame. But if I use my right and left arrows to step down the frame number, you'll see it goes green. And it means this property has been animated, but it doesn't have a value for the current frame. If I go down to 0, you can see it goes yellow again. And you can see that my zone now rotates according to the frame that I switch to. And that's, a very simple, easy way of setting up an animation, and it's how Blender does animation setup in all sorts of different areas. So once that has become set up, we can now go ahead and proceed with the parametric simulation. Now I will just mention, while I think about it, if we come into the graph editor window, we can see that animation change. 0 at frame 0 to 360 at frame 10. And we'll notice that this is a straight line, which means every time I change one frame, an equal degree rotation will be enacted. This isn't, however, how Blender is initially set up. If I come into the user preferences, and if I come into editing, this new F-curve defaults interpolation option is by default set to Bezier in Blender, which would mean this straight line would be a curve. So you'd get smaller steps at the beginning and smaller steps at the end. So it's a good idea, if you're looking at linear transformations, to set this option to linear in the user preferences. And if you've set up a Bezier curve and you want to change it to a linear, or vice versa, you can come into key, interpolation mode, and you can pick Bezier or linear here. But I want equal angle changes per frame change, so I'm going to have it as linear. So we can now come into the node editor. I can now turn on animation, and I can say, right, we've got an animation set up from frame 0 to frame 10. And that's all we need to do. But I do need to export the geometry because it's the geometry changing. And I can export this. And now in my EnVi simulation node, I should now have a multi-core option. And that allows you to run the different scenarios simultaneously on the different cores of your computer processor. So I've got a 16-thread machine, and I've got 11 frames or 11 scenarios. So I'm going to put one scenario per thread on my computer just to speed things up. So I can now press calculate. And that should be pretty quick as I'm using the multi-core capabilities. And once that's done, then we should notice a couple of things. We've got this animated option in the CSV export node. And we've also got, I might just need to update the node links. We've also got now a parametric option here. So I can now, with this parametric option selected, I can now plot frames along the x-axis, and I can plot metrics along the y-axis. So for example, the total amount of heating that was required in each scenario. So I can create that plot. And so for each frame or each parametric scenario, with our room rotating round, window to the south, window to the north, window to the south again, we can see that the heating requirement goes up as the window turns more to the north and comes down as the window turns more to the south. And in effect, we're getting more solar gain at these times. And we can see that if we look at total solar heat gain, we get the opposite curve. Low when the window points north, high when the window points south, low when the window points north. And if we export a CSV file, then we should now see that in this file here, although I didn't want to open it with LibreOffice, but we have the frames, and then we have different metrics for each of the frame. So that allows you to then plot out, however you want, a comparison between scenarios. In addition, we now have, in the vSuite Display tab, we now have the option to go parametric with display results. If we stay on static, then we can now simply pick the frame that we're interested in, or the scenario that we're interested in, from 0 to 10. And then all the other options are the same as for a static display analysis. But if we come to parametric, we can pick the frame of ranges that we want to display. And then if we click EnVi display, we've now got this new icon up here, this bar chart icon. And if I open this, this will now show me the metrics selected down here for each of the frames. So total solar heat gain, for example, again, high when the window points to the south, low when the window points to the north. And I can, if I want, change the color scaling of that bar graph to be something a little bit more indicative. And I can change what the color of that is going to be as well. The tabular display now shows the average, the minimum, average, and maximum over all the scenarios for the different metrics that we had selected. So a pretty quick and easy way of doing a comparison between different scenarios. Now, in reality, you may not have a choice when designing a building to have it painting or pointing in whichever direction you like. But there are certainly more subtle changes to the building that you might want to investigate or have some control over. So the second way that we can set up a parametric simulation is by changing the mesh of the object itself rather than the object. So to begin with, I'm gonna, because I have left click select in the options for Blender, if I right click on this keyframed property, I can now select clear keyframes. So if I now do my right and left arrow to change the frame number, that animation has gone from the object. And what I'm instead going to do is I'm going to add some shape keys to the object, and that allows me to animate the underlying mesh. So in my object data panel, under shape keys, I'm going to add two shape keys. The first one is called basis by default, and the second one is called key 1 by default. With the key 1 shape key selected in here, I'm going to go into edit mode, and I'm going to move that window edge over to there. And I'm going to tab out of edit mode. Now, once I tab out of edit mode, the object goes back to the way it was originally. And that is because the value associated with this key 1 keyframe is 0. But if I change it, I interpolate between the original mesh configuration and the modified mesh configuration. And it is this value of this keyframe, this value of this shape key that we're going to animate. So once again, I come to my first frame, 0, and I press I over this value. And then I come to 10, move my value to 1, and press I again. And again, once that value is registered to a particular frame, it'll go yellow, and it'll be green for the intermediate frames. So we can now see we're interpolating that window size between our frame numbers. So everything else pretty much proceeds as before. I'm going to export my geometry. because it's a geometry change I've made. My frame range is right, so I'm just going to export that. Click calculate. Again, pretty quick. And now, for example, I could look at, solar heat gain again. So we can see as the window gets bigger, and it gets linearly bigger by the same amount every frame, then our solar heat gain goes up linearly as well. And again, EnVi display, we can see our solar heat gain, can see our average heating. And I've covered this in a previous video, but if you click on this graph, you will open up a matplotlib window, and you can then change the scaling of the axes and the titles, etc. And I think that's everything for the second method. So I'm going to get rid of these shape keys, and I'm going to now do the third method, which is where I change a parameter or a number of parameters. And bear in mind, all three of these methodologies can be combined. So if you've got different types of animations within, as in this case, the frame range 0 and 10, they will all get simulated, exported and simulated. But for this final one, I'm just going to animate a particular property. And the property I'm going to animate is the thickness of the insulation within these walls. So if I come to the Material tab, make sure Walls is selected, come down, and this is my insulation, thickness of insulation within my wall construction. It's currently 50. So again, I make sure I'm at frame 0. Keep it at 50, press I. That's now keyframed, come to 10, enter 300, insert keyframe again. And now we should see, as I change frames, this number of insulation thickness changes with it. So again, I'm going to export, calculate, and now I can display again, and we can see heating required for the room goes down as the insulation goes up. I can change my scaling a little bit again. Solar heat gain, this will be the same. That won't change because we haven't changed the window, only the insulation of the opaque fabric. And yeah, the average temperature within the space, again, doesn't really change because we've got a thermostat, which is putting the minimum temperature at 20 degrees Celsius. Slight decay in the max temperature. And that's pretty much all the basics of setting up parametric simulations in EnergyPlus. You can do all sorts of animations. You could, by pressing I, animate what weather file you're using. You could change these. I wouldn't recommend it. I wouldn't recommend really animating anything within this node, as this is a general simulation context node. But certainly in terms of the parameters around thickness of your walls, the geometry, material specifications, that can all be keyframed in Blender. We could come in here and we could change the thermostat level. We could change what kind of heating system it's got. And that applies to zone, occupancy, equipment, infiltration, all the sort of EnVi network nodes as well. So there's a lot of potential for setting up the parameterization of individual or groups of variables within the simulation. And I believe that's everything I have to cover in this video. Okay, thanks for watching.